So in this particular video, we have a block of 2 kilograms that is free to move along the x-axis. It is at rest at times equal to 0. So essentially, the object is starting at rest. And then it says it's subjected to a time-dependent force, F of t. And then essentially it asks us to find the kinetic energy of the block at 4.5 seconds. So the graph here is an F of t graph. So here's F in units in newtons. The diagram said so. And here t is in seconds because it says here is 4.5 seconds. So everything is already in the proper units as we need. Alright, so here are the answer choices A, B, C, and D. So let's go ahead and find the kinetic energy at 4.5 seconds. Well, to find the kinetic energy at 4.5 seconds, I'm just going to start with what it asks for, Ke. Ke is 1/2 mv squared, m being the mass of the object, v being the speed of the object. So here, I can just plug in mass being 2 kilograms because the problem said so. The only thing I don't know is the speed at 4.5 seconds. But what I do know is that this is an F of t graph. So essentially, I can find the velocity just using impulse. All right. So I'm just going to go ahead and apply my impulse statement. Impulse, capital I here, is equal to the change in momentum. Well, the change in momentum is simply the final momentum minus the initial momentum. But momentum is composed of mass times the final velocity. Therefore, pi here is just mass times the initial velocity. Well, I know the initial velocity is 0 because the problem says that it is at rest at times equal to 0. So because it starts at rest, there is no initial momentum, so I want to cross that out. So the only thing I'm left with really here is just I equals m times the final velocity at 4.5 seconds. Okay. The problem wants us to find the kinetic energy at 4.5 seconds. So my goal here is just to find the velocity at 4.5 seconds. Once I do that, I know what the speed is because the speed is just the magnitude of the velocity. All right, so to find VF, all I have to do really is find the area of this F of t graph because impulse is the area underneath the F of t graph. Okay, so I made a note here for you. I circle capital I because capital I is for impulse. And from this particular F of t graph, how do you find impulse? Just find the area. If it's above the t-axis, positive. If it's below, it's negative. So let's go ahead and solve for VF by dividing, let's go ahead and just find the area real quick here. Okay, I got ahead of myself here. The area here for the top portion of the graph, you notice here, it goes all the way to 3 seconds on the horizontal axis, which is time. And the rise here is 4 newtons. So I'm just going to do 1/2 times base times height. This is a right triangle, so it's just 1/2 times base times height. Therefore, the base here is just 3 because from 0 second to 3 second is where it intersects the t-axis. And then the height of this particular right triangle is just 4 newtons. So 3 times 4 is 12, and then 1/2 of 12 is just 6. So this first area is a positive 6 because it's above the x-axis. And then the area beneath the t-axis here is simply just the base times the height. But you notice here the base is super easy to find. It's just 1.5 because it starts at 3 seconds and it ends at 4.5 seconds. So the difference here is just 1.5 seconds. However, the vertical one is not so straightforward. Okay. Here I bracket this because I actually don't know what it is. In the graph here that's initially given to me in this problem, or this problem that I found online, I actually don't know what it is on the y-axis at 4.5 seconds. And you can make an assumption if you want, but I'm actually just going to show you how to find what the value is on the F of t graph here. Okay. So here I know this is a straight slope, so I'm just going to use y equals mx plus b. Because it starts at 4 newtons and it goes to 0 and then it ends at some value at 4.5 seconds, which I cannot assume. Here, y equals mx plus b is applicable because this is just a linear diagonal. But what I want to do is instead of y, I'm just going to apply it for physics here. So instead of y, my vertical is f of t. And then my slope here is -4/3 because I want to go down. Because when you do slope, you go from left to right and then, down. Okay, so here's down, which is -4, and then right 3. Okay, so down is -4, and then right is 3. And if you've been taught slope, you know by just looking at it, this is a negative slope. Well, what's the slope? I'm just going to use where it touches the initial point at times equal to 0, and I'm just going to go to 3 seconds. So therefore, rise is -4, and then the run here is just 3. And my independent variable, excuse me, is just t, and then plus 4, which is your y-intercept, and essentially that's just your initial value, and it's 4 because at times equal to 0, f of t is equal to 4. So y equals mx plus b just gets applied to physics here. But now that I know the function for this line, I can just really plug in 4.5 seconds because I don't know what the value of f of t is at 4.5 seconds. But now that I have the function for f of t, I can just plug in t. So in my next line here, I just plug in f of t. So therefore, I can just find what is the value of f of t at 4.5 seconds. So in parentheses here, this is time is equal to 4.5 seconds. The slope, once again, just gets carried down. It's negative 4 over 3. Time here is 4.5 seconds plus the y-intercept, which is 4 for this particular graph. And if you simplify that on your calculator, you'll get that at 4.5 seconds, the f of t value should be negative 2. So I'm just going to go ahead and label this as negative 2. Okay. So it's important that you know this kind of strategy. Otherwise, you don't know what this value is, and you can end up playing the guessing game or just crack it out and know what the actual value is. So now that I know this is negative 2, I can find the area of this particular yellow right triangle. So it would just be 1/2 times base times height. So 1/2 times 1.5 times 2. I know it's negative 2 here in the diagram, but I'm just finding the area. So really, it's just 1/2 times 1.5 times 2. I highlight this 2 because this 2 here is what I found using the y equals mx plus b function. Okay? All right. But we know the area is 1.5. However, keep in mind, the area of this yellow triangle is 1.5, but because it is beneath the horizontal axis, which is your time axis in this case, it is a negative value because impulse is a vector quantity. So back to my statement earlier, I have I impulse equal to final velocity, mass times final velocity. So therefore, to find final velocity, I would just divide both sides by m. But here, you notice in the numerator here, I have a positive 6. Well, why? Because the first 3 seconds, the area is a positive 6. And then from 3 to 4.5 seconds, we found the area to be 1.5, but it's beneath the t-axis, so it's actually negative. So in my work here, I highlight this negative sign because you end up adding a negative, or you can just subtract it from itself, okay? So here I have 6 minus 1.5 divided by 2, 2 being the mass of the object given in the problem. So if you simplify this on your calculator, the final velocity would be 2.25 meters per second, okay? Or the final speed here would be 2.25. So here in KE, the only thing I was missing earlier is this V here, which is the speed. But now that I know the speed here is 2.25 meters per second, I can just plug it in. So 1/2 times 2 times 2.25 square. The 1/2 and the 2 kilogram for this particular problem will cancel out. And therefore, really, KE is just 2.25 square. So if you square that on your calculator, you should get about 5.06 joules. And it matches with choice C, okay? So again, this is just a multiple choice question I found online. I think it touches some good concepts here. 1 on impulse, 2 on slope intercept form, and then 3 on kinetic energy. All right, so the answer is just BC for this particular given problem. I hope that helps. Stay nerdy, don't be whack.